All right, there's all kinds of exponential equations, and there's a certain style or type of exponential equation that is most easily solved if you rewrite one or both sides of the equation as you rewrite it so that it's some number raised to a power, so that both sides of the equation consist in that same number, the same base, being raised to different powers, and then those powers you set equal to each other. So let me show you. We'll start with something very simple and then kind of expand from there. So here's an exponential equation. The variable is an exponent. So 2 to the power of x equals 4. Well, you can probably eyeball that and say it's 2. X is 2 because 2 to the power of 2 is 4. 2 squared is 4, right? But let me show you what you can do with this. This is equivalent to saying 2 to the power of x is equal to, well, I could rewrite 4. 2 to the power of 2. 4 is equivalent to 2 to the power of 2, right? So I've got this base in common, some base being raised to a power and some base being raised to another power, but these bases are the same. Well, it follows then that I could set x equal to 2 and then solve. Well, boom, it's already solved, right? So in other words, I'm taking some number and I'm raising it to a power, and that's equal to that same number raised to a power. Well, the only way for these things to be equal, since they have the same base, is for the exponents to equal each other, right? If I've got 3 to the power of 3, what do I have to raise 3 to the power to what? No, to what power do I have to raise 3 in order to make it equal to 3 to the power of 3? Well, 3, of course, right? Well, same situation here, except there's going to be variables, maybe even like longer expressions like that, minus, right? But the principle is, if I've got the same base, the exponents, the powers, have to be equal to each other so that the equation is true, that it's equal. Okay, so let's try a little bit more complex example, but it's based on this principle. So we've got 3 to the power of x plus 1 is equal to 27. So question, can I rewrite one of these numbers so that it has the same base as the other? In other words, well, 3 is a prime number. There's not much I can do with that. But is there a way to rewrite 27 so that it's expressed as 3 raised to some power? Because if so, then I can set x plus 1 equal to that power. Well, 3 cubed is 27, right? 3 squared is 9. 3 times 3 is 9. Times 3, 9 times 3 is 27. So 3 cubed is 27. So I'm going to rewrite that so that it's a number with the same base as this number. So 3 to the power of x plus 1 is equal to 3 to the power of 3. So that must mean that x plus 1 is equal to 3. Well, subtract 1. You can see that it's 2, right? It's 3 minus, yeah. So 3 to the power of 2 plus 1 is equal to 3 to the power of 3, right? So, another pretty simple example, but really these types of problems are no more complex than that. All right, here we've got 256 to the power of x is equal to 4 to the power of 2x plus 1. Well, this looks hard, but it's not really. If I can rewrite 256 as a power of 4, I should be golden. Well, if you don't have these things memorized, you can get out a calculator. That's fine. So 256. I want to see if that's some power of 4. Well, that's kind of the point of logarithms, right? So I want to say what I want to know is log base 4 of 256. Can I express 256 as some power of 4? In other words, to to what power do I need to raise the number 4 to turn it into 256? Now on your calculator you don't have a button that says log base 4, but you can use a change of base property to say log base 10 of 256. Say this is equivalent to log base 10 of 256 over log base 4. It's equivalent. Get out the calc. Log 256, and that's base 10. You know, just if it just says log, that means base 10. 256 divided by log 4, it's 4. So that means 4 raised to the power of 4 is 256. So I'm going to rewrite 256 as 4 to the power of 4. Right. Now, don't forget this x. So 4 to the power of 4 to the power of x is equal to 4 to the power of 2x plus 1. And remember the properties of exponents. If I raise a power to a power, I multiply the exponents. So this is equivalent to 4 to the power of 4x, just multiplying those exponents. So 4 to the power of 4x is equal to 4 to the power of 2x plus 1. Therefore, 4x is equal to 2x plus 1. So, subtracting, to get the x's on one side, 2x is equal to 1. So x is 1/2. Boom, that's it. Right? Not too bad. Looks crazy, right? Not too bad. Let us try one more. Okay, so we've got 9 to the power of 5x equals 27. Now, can I write 27 as some power of 9? You know, log of 27 divided by log of 9, 1.5. I could do that. I could say 9 to the power of 1.5. Or check this out. I could rewrite both of these numbers. I could see how they share the number 3. I could rewrite 9 as 3 squared. 3 squared is 9. So I could rewrite this as 3 squared to the power of 5x is equal to 3 cubed. 3 cubed is 27. Now I've got the same base, so I need to do this thing. So I'm going to multiply the exponents. So 3 to the power of 10x is equal to 3 to the power of 3. So therefore 10x equals 3 divided by 10. So x equals 3/10 or 0.3. So not too bad. So think of ways in which you can re-express numbers so that it's some other number raised to a power, so that both sides of the equation are some common base raised to powers, and then it gets pretty easy to solve, as you saw.